Hello friends, welcome to Best Tutor. This is Rama Vishwanathan. In today's video we are going to learn about linear inequations where particularly the replacement set is a set of real numbers. What is so particular about real numbers? Real numbers is the set where the number line is very dense. So we need to be very particular about that. Linear inequations the solving and the entire thing remains the same as in the case of natural numbers, whole numbers and integers, excepting the solution set, representation of the solution set and representing it on the number line varies. So let us choose an example. 2y minus 3 is less than y plus 1 is less than or equal to 4y plus 7 where y belongs to R. This is a double inequation. We need to split the inequations. This y plus 1 is the common part, it will be shared with both the inequations. So we are going to split it separately. 2y minus 3 is less than y plus 1. 2y minus y minus 3 is less than 1. We have transposed this to the other side. So we have y, 2y minus y is y. Minus 3, if we transpose that side, it will become 1 plus 3. Y is less than 4. So this is the solution for the first pair of inequations. Now first inequation, now second one. Y plus 1 is less than or equal to 4y plus 7. Our intention is that y should always be positive to avoid confusion. So I will take this y to the other side. 1 is less than or equal to 4y minus y plus 7. I will transpose this 7 to this side. It will become 1 minus 7 is less than or equal to 4y minus y, which is 3y. So minus 6 is less than or equal to 3y, minus 6 by 3 is less than or equal to y, or minus 2 is less than or equal to y. So we have got two solutions for the inequations. Now the combined solution set is y is greater than or equal to minus 2 but less than 4. How are we going to write down the solution set? Are we going to write down the solution set in roster form? Or does it work out, or should we write it in set builder form? All the values, all the real numbers which are in between minus 2 and 4, all those satisfy the given condition. How many values, how many real numbers are there between minus 2 and 4? Can we write them in order? Is it going to be minus 1, 0, 1, 2, 3, 4 or more than that? Actually, there are infinite real numbers between minus 2 and 4. The real number line is very, very dense. So we cannot represent that using roster form. So the solution set is going to be y such that minus 2 is less than or equal to y less than 4, where y belongs to the real number system, real number set. So this is a solution set. So number line also is going to be dependent upon the solution set. How are we going to represent it on the number line? This is a number line. It should have arrows on both the sides, as I told you. It is a line. So we have minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6. It's always advised to write two neighboring numbers on both the sides of the solution set, right? These three dots represent that the number line is infinite, not the solution set. Solution set depends upon the solution set. We can't just decide whether it is infinite or finite, right? Now here minus 2 plus 4. So these are the boundaries of the solution set. Here minus 2 is less than or equal to y. So y can be greater than minus 2, y can be equal to minus 2. So this should be highlighted, right? So minus 2 onwards, minus 2 is included. So this dark circle shows that it's included. And 4 is going to be a hollow circle because y is strictly less than 4. That means, should I start from 3? No. Just beside 4, we have infinite real numbers. So we can't just choose 3. If we choose 3 because it is less than 4, if I start choosing 3, I am going to skip out infinite real numbers here. So which is going to be wrong. So I have to choose all the real numbers which are just left of the 4 but not 4. So I am going to mark it as a hollow circle. And in between these two, all the real numbers are included in the solution set. So this is the procedure to write down the solution set, and this is the procedure to write down the draw the number line, represent the solution set on the number line. Okay. Now if there is a change in the question, if we have 5x minus 8 by 3 is greater than or equal to 4x minus 7 by 2, comma x belongs to R. Okay. This is not a double inequation, it is a single inequation, and x belongs to real number. That means the replacement set is a real number set. Okay. Now how do I simplify this? First step is cross multiply. Cross multiplication is applicable only when we have two fractions on either side of the equation or inequation. I don't mind whether it is an equation or an inequation. If we have two fractions, you can cross multiply, provided this symbol does not change. Okay. 2 into 5x minus 8 is greater than or equal to 3 into 4x minus 7. Now open the brackets. 10x minus 8 to the 16 is greater than or equal to 12x minus 21. Now we need to simplify this simple linear inequation, and we want to make the variable positive. So I will transpose this 10x to the other side of the equation. Minus 16 is greater than or equal to 12x minus 10x minus 21. Minus 16 plus 21 is greater than or equal to 2x. So it's going to be 5 is greater than or equal to 2x. 10x minus 16 is greater than or equal to 12x minus 21. This 10x was transposed to the other side of the inequation. So 12x minus 10x is 2x. This minus 21 was brought this side. 21 minus 16 is 5. So 5 by 2 is greater than or equal to x, or x is less than or equal to 5 by 2. 5 by 2 is nothing but 2.5. So x is less than or equal to 2.5. So what will be the solution set here? Solution set is going to be x. We cannot write it in roster form because here the replacement set is real numbers. So we can't write it in roster form or listing method. We need to use only set builder form or rule method. What is the rule here? X is such that x is less than or equal to 2.5 and x belongs to R. Okay. Now how do I represent it on the number line? I want 2.5 to be highlighted on the number line. 2.5 lies between 2 and 3, exactly in between 2 and 3. So 2, 3. I would prefer to write down two neighboring numbers. Exactly here 2.5. I want all the real numbers which are less than or equal to 2.5. Less than means always towards the left hand side. Greater than means towards the right hand side. Less than left hand side. L you can remember in that way. First of all, 2.5 has to be highlighted. Is it going to be a dark circle or a hollow circle? We need to decide, and that is dependent upon this inequality. If it is a strict inequality, we are going to leave it as a hollow circle. If it is not, we are going to highlight it. Here it is not a strict inequality, so it should be darkened. Right? This is a dark circle, and all the real numbers towards the left of it. I just leave an arrow. This shows that this is indefinitely extendable towards this side. So all the real numbers towards left of 2.5 as well as 2.5 included. This is the real number line, and this is the solution set. So we were given a simple linear inequation which consisted of two fractions on either side. We cross multiplied and then we simplified. We got the solution as x is less than or equal to 2.5. We have written the solution set in the set builder form, and then we represented it on the number line using the number line, right? So today in this video we have learned how to solve a linear inequation when in particularly the replacement set is the real number system, real number set. So set of real numbers is a replacement set here. So accordingly the solution set representation has changed as well as the number line has changed. In the earlier videos where we have observed replacement set is natural numbers or whole numbers or integers, solution set was written in roster form, and the number line had individual numbers which were highlighted. It is not the same with the case of real numbers. Solution set is in set builder form, and number line we have continuous line. We are not going to highlight each and every number. It is not possible for us to highlight each and every real number, and the reason is in between two very close real numbers we can give infinite real numbers. So it is not possible for us to highlight every real number. So instead of that we just highlight the entire line, continuous line. Right? So this is a procedure to find out the solution of a linear inequation, find the solution set and represent it on the number line. We need to be very careful in representing the numbers. If it is 2.5, it is between 2 and 3. If it is 2.4, we have to write it in the fractional form and then exactly mark it in between 2 and 3. That has to be observed carefully and marked. Right? Thank you. In the coming videos, we are going to learn about many more concepts of mathematics. Thank you.